Hello everyone. In this video, let's learn how we can design the SR latch circuit using NAND gates. In the previous video, we saw how we can design the circuit for the SR latch using NOR gates. So let's quickly recall this. So the circuit using NOR gates, we had two NOR gates. One will output the Q state, and another one will output the Q bar state, which is the complement of Q. The one that output the Q state, one of its inputs for the NOR gates is the reset, and then the one that output the Q bar, one of its inputs is the set. And then a Q will be another input for the bottom NOR gate, and a Q bar will be the input of the top NOR gate. Now let's see how we can design the circuit using NAND gates. So it's very similar. So we can use two NAND gates. One will output Q state, and another one will output Q bar state. But the top NAND gate will have the input as S bar, which is the complement of S set, and then the NAND gate that output Q bar will have one of its inputs is the R bar, which is the complement of the reset. And then similarly, Q will be the other input for the bottom NAND gate, and Q bar will be the other input for the top NAND gate. So next we want to derive the state table of the SR circuit using NAND gates. So let's quickly recall for the SR possibilities. We had 0, 0, 0, 1, 1, 0, and 1, 1. Because two inputs will have four possible combinations. So what will be S bar R bar? Is the complement of the SR. So in the first row we'll have 1, 1, next row we'll have 1, 0, next row will have 0, 1, and then last row will have 0, 0. So now let's derive the state table of this circuit here. So this is S bar, R bar, and then we have the Q is the current state of the system, and we want to figure out the next state. So Q, as we said, we don't know the current state of the system. Could be 0, or could be 1. So that's why when we derive the state table, we want to consider both. The state could be 0 and could be 1. So that's why each one of these we'll write it twice. When we figure out the state table, we can just write four combinations, four possibilities. So S bar, R bar, first we have 1, 1. We'll write it twice because Q, the current state could be 0. We want to analyze what happened if it's 0 and what happened if it's 1. Next, we have the 1, 0. So we have 1, 0. We'll write it twice because also we want to see what happened when the current state is 0 and what happened when the current state is 1. So third, we have 0, 1 for the S bar, R bar. So that's 0, 1. Also, we'll write it twice because we want to analyze our circuit for current state 0 and if current state is 1. And lastly, we have the 0, 0. Also, we'll write it twice. We want to see what happened when the current state is 0, what happened when the current state is 1. So that's why we said we have four cases. This is case 1, case 2, case 3, and lastly case 4. So let's try to figure out what is the next state in each case. So this is case 1. In case 1, we have S bar is 1 and R bar is 1. So this is S bar equal 1 and R bar equal 1. So first row, we assume the current state of the system Q is equal to 0. So we want to figure out what is the next state. So we want to do one loop. So when Q is 0, Q will come here. So this is 0. I mean, we can write also the table of the NAND gate. So the state table of the NAND gate, or the truth table of the NAND gate. So we have two inputs, I1 and I2, and we have the output O, let's call it. And 0, 0, 0, 1, 1, 0, and 1, 1. So for the AND gate, the output is 1 when both inputs are 1, but the NAND gate is the opposite. So for 1, 1, we get 0, and then the rest are 1s. So let's go back to our circuit. So now for this NAND gate, we have 0 and 1. So that's 0 and 1. The output will be 1. Now this Q bar will come here. So for the top NAND gate, we have 1 and 1. 1 and 1 will output 0. So now we know the next state is 0. So we can write 0 here. Now let's analyze the system for S bar equal 1, R bar equal 1, but the current state is 1 instead of 0. So Q equal 1. Same idea, Q will come here. So we'll have 1 and 1 for the bottom NAND gate. 1 and 1 will give us 0. So now we have Q bar is 0. 0 will come here. So we'll have 1 and 0 for the top NAND gate. 1 and 0, the output is 1. So the next state in this case is 1. So we can write 1 here. Now for case 2. Case 2, S bar equal 1 and R bar equal 0. So this is 1 and R bar is 0. Let's start by assuming the current state Q is 0. So 0 will come here. 0 and 0, the output is 1. 1 will come here. The top NAND gate, we have 1 and 1. So 1 and 1 will give us 0. So we have 0 here. Now, in case 2, let's assume the current state Q is 1. And we want to figure out the next state. So if Q is 1, 1 will come here. 1 and 0, the output for Q bar will be 1. 1 will come here. 1 and 1, the output is 0, so Q plus will be 0. So we write 0 here. Now case 3, we have S bar is 0 and R bar is 1. Let's assume the current state of the system is Q is 0. So 0 will come here. We have 0 and 1 for the bottom NAND gate. So Q bar will be 1. 1 will come here. So the top NAND gate also 0 and 1. So Q plus will be equal to 1. Now let's see what happens if Q is 1. So let's assume the current state is 1. So 1 will come here. The bottom NAND gate, we have 1 and 1. So Q bar will be 0. 0 will come here. So we have 0 and 0 for the top NAND gate. So Q plus will be 1. Now the last case, case 4. So in case 4, S bar is 0 and R bar is 0. Let's assume the current state of the system is 0. So 0 will come here. So 0 and 0 will output 1. So Q bar will be equal to 1. 1 will come here. The top NAND gate, we have 0 and 1. 0 and 1, so Q plus will be 1. We have to notice that at this loop, Q plus, the next state Q is 1 and Q bar is 1, which is not possible. So that's why we say this is invalid. So now we can write the state table for the SR latch using NAND gates. So let's rewrite it here. We have S bar, R bar, and let's just write the next state Q plus. When S bar is 1 and R bar is 1, we can clearly see that Q plus, the next state, is the same as the previous state. So that's why we say hold. In other words, we hold the previous state. So the next state will be the same as the previous state. From case 2, we had S bar is 1 and R bar is 0. If we come look here, the next state will be 0, no matter of the current state of the system, whether it's 0 or 1. So in here we get 0. From case 3, we have S bar is 0 and R bar is 1. And also if we look at the next state, it's 1 whether the current state is 0 or the current state is 1. So from here we get 1. And then lastly, when S bar is 0 and R bar is 0, this is not allowed or invalid. So this is all about the SR latch using NAND gates.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.